important renal tubular acidoses that you want to know further. And really, this kind of summarizes the two that you need to know down the collecting duct. So let's keep it simple. You need to know about 1, 2, and 4. Do you remember 2? You do. How many lines do you need to form an X? 1, 2. What part of the nephron requires an X? Proximal convoluted tubule. Are we clear now? What was my problem with proximal convoluted tubule RTA type 2? There might have been an issue with your carbonic anhydrase. Do you remember that discussion that we had quite extensively? Let's now jump over and skip down to the distal convoluted tubule, please. In the distal convoluted tubule, we'll first take a look at type 1. Now, it could be in the collecting duct distal region. Okay, so do not get hung up for the exact location. That is going to be, at this point, not the best use of your time. The best use of your time at this point is that you know that you're not in the proximal convoluted tubule. So what is going on with type 1? Now, the details as far as how this occurs is a little theoretical, but all we know for sure is this first bullet point for type 1 RTA, distal, impaired excretion of hydrogen. When you say renal tubular acidosis, a couple things automatically come to mind. That acidosis is referring to your pH in your blood, not your urine, in your blood being decreased. Number one, how did this occur? In the distal convoluted tubule, you were not able to properly get rid of your hydrogen, therefore it remains within the blood. What happens to your pH? Whoop, drops. Next, as I said, unclear in terms of its etiology, hydrogen remains back in your blood, results in severe non-anion gap metabolic acidosis. What does that mean to you? Let's think together. When you do metabolic acidosis, you're going to do anion gap. Always. So, metabolic acidosis, anion gap. That should be next step in terms of diagnosis. What does an anion gap mean to you? It's your cations minus the anions. Your cation is your sodium, and your anions are your chloride and bicarb. When you do that formula, you end up getting a normal anion gap between 8 and 12. Clinically, we call this a non-anion gap. Okay? Severe, though. Severe. Now, the causes include the following. Now, these are things that you're looking for underlying or type 1. Maybe it's do, re, mi, fa, sol, la. What am I talking about? What is this? This is ro, and you've heard of la. Or in other words, SSA and SSB. Really? Remember, clinical practice, all jokes aside, clinical practice, SSA and SSB is huge for you to diagnose Sjogren. Sjogren. SSA is going to be Rho. SSB is going to be La. Okay? If you want, you may want to use lab. La is SSB. Rho is SSA. What's my diagnosis? Autoimmune disease called Sjogren. Type 1, RTA. Tell me about Sjogren. No tears. Xerophthalmia. Lacrimal gland had been knocked out. Autoimmune disease. What about your mouth? No saliva. You can't protect the teeth. Maybe dental caries called xerostomia. Right? Sjogren. Number one distinguishing feature, dryness. Autoimmune diseases. Sjogren. Children, hereditary transport defect. Of what? Hydrogen. That's type 1. So type 2, proximal convoluted tubule. You cannot reabsorb bicarb. Welcome to RTA type 2. RTA type 1, distal. Can't get rid of my hydrogen. Let's go into type 4. Type 4, renal tubular acidosis. Hypoaldosteronism. If you don't have sufficient amounts of aldosterone, hence the time that we have spent on truly understanding aldosterone. And at some point, maybe you even got bored, which is a good thing, which means that you know aldosterone in and out. So based on that, you tell me what just happened. If for whatever reason aldosterone is not present or inadequately present, then your sodium is not being properly reabsorbed. Look for decreased sodium. Okay, fine. Next, what about potassium? You can't properly get rid of it, so you may result in hyperkalemia. Okay, fine. I understand electrolytes, Dr. Raj. Get to the point. Renal tubular acidosis. This is the only one in which you would have hyperkalemia and you can't get rid of the hydrogen, what happens to your pH, please? There you go, acidosis. So type 4 renal tube acidosis is as simple as understanding that there's either aldosterone inadequacy or there's resistance to that aldosterone, resulting in acidosis with prominent hyperkalemia. Did we see such a thing with type 2 RTA? No, we did not see hyperkalemia in type 2. What about type 1? We did not see hyperkalemia in type 1. In type 1, the hydrogen, for unclear etiology, know that, you're not able to properly secrete your hydrogen. In type 2, one more time, maybe it's issues with your carbonic anhydrase. And just to be technical, in the proximal cavity tubule with type 2, maybe you're not able to get rid of that hydrogen. So therefore resulting in RTA 1, 2, and 4. This would be a good time for you to review all of the 3 major renal tube acidosis, metabolic acidosis, non-anion gap type of issues. What about type 3, Dr. Raj? Let it go. Please? Can you do that for me? Type 1, 2, and 4 is what you pay attention to, period. Clinical findings of Addison's. You find this to be interesting. In Addison's disease, let's stop here. What does that mean? I want you to take the ADD in Addison's. What's that say? What's that spell? Add. Yeah. So you're adding hormones to this disease. There you have it. So what ends up happening primarily is that the adrenal gland is primarily, boom, destroyed. So that adrenal gland is gone. It's destroyed. What do you need to do? You need to add hormones. Is that clear? So what is this called when your adrenal gland is dead and you don't have, number 1, aldosterone. Number 2, what's a fasciculata? Cortisol. You don't have that either. And those are 2 that you want to pay attention to because that will then give you the diagnosis of Addison's. For right now, since we're doing nephrology, let's stick with the aldosterone, shall we? Thank you. So this is primary adrenal insufficiency, a.k.a. Addison's. Okay? If you don't have your glomerulosa working properly, you don't have aldosterone, can you then walk me through and may result in walking in renal tube acidosis? Type 4. Good. Hyponatremia, hyperkalemia. You get that? I'm not going to cover that again. We've done that plenty. Due to inhibition of sodium reabsorption, potassium excretion. Hypertonic loss of sodium in the urine. It's a salt wasting disease. Salt wasting disease. What kind of question are you going to get here in physio? Let me walk you through this. You're losing fluid. What happens to ECF? You're losing fluid. What's the first compartment that you always pay attention to? Work with me here. Look at me. What's the first compartment you pay attention to? It's always a plasma compartment. Where is the plasma compartment? In the ECF. Are we good? You're losing fluid. Plasma compartment contracts. ECF compartment contracts. Stop there. In Addison's disease, you're losing a lot of, look at what that says, hypertonic loss of sodium. So you're losing fluid, granted, but you're losing a lot of solute. So ECF osmolarity decreases. ECF volume decreases. Number 3, if your ECF osmolarity decreases, where are you going to go? Into the ICF. Are we clear? If you go into the ICF, what happens to ICF volume? Expansion. Good. If water goes into the ICF, what happens to ICF osmolarity? Decreases. Do you see how simple this is? When you understand the physio, you can bring in the clinical application. You don't have to sit there and memorize. But you go through that order every single time, you're in good shape. ECF volume, ECF osmolarity, ICF volume, ICF osmolarity. In that order. Por favor. Next. Retention of hydrogen. What does it cause? RTA type 4.